Okay, moving on and working on practice problem number 4. Practice problem number 4 says if 10 mLs of a solution are to contain 3 milliequivalents of sodium ion, how many 1 gram sodium chloride tablets would be required to compound 250 milliliters of the solution? So we need to find out first how much the 10 milliliters weigh, how many tablets would make that, and then how many would go into the 250 milliliters. Okay, so again, we are working with milliequivalents. Don't get tired of me saying this, but every time I see milliequivalents, I'm going to remind myself, the more I write it, the more I will know it. Milliequivalents is equal to weight in grams divided by molecular weight, grams per mole, times valence. Our special valence isotopes will be compounds, ammonium, potassium, chloride, and sodium. Those will all have a valence of 1. Calcium and magnesium will have a valence of 2. Yes, I know these. I know them because I write them every time. Okay, and let's see. I have 10 milliliters of a solution that contains 3 milliequivalents of sodium ion. So what is that telling me is that I have 3 milliequivalents of sodium ion in 10 mLs. That's just a concentration there. Easy to work with. What I don't know is the concentration with the weight in milliliters there of what I'm working with. So let's go ahead and find that. 58.5 grams per mole. And of course my, let's see, valence is sodium. Oh, there it is, 1. Okay, so let's solve for W. I'm going to have 3 milliequivalents over 10 milliliters. And flip-flop, 58.5 grams over mole, or grams per mole, and times 1. So I'm going to go ahead and let that one be, and that is my weight. Do some math here. We have 3 times 58.5 divided by 10, and that gives us a weight of, well, no, what does that give us? Well, let's go ahead and write that down in units. 17.55 milliequivalents grams over milliliters mole. And let's go ahead and work on getting rid of some of these units here. So milliequivalent, 1 millimole is equal to 1 milliequivalent. Need to get rid of that mole though, and so we have 1 mole is equal to 1,000 millimoles. And let's see, that got rid of that, and that, that, and that, and that. Okay, and so now I just need to divide by 1,000. And that is going to leave me with a weight of, well, my concentration, if you will, of sodium ions, and that 10 ml is going to be 0.01755 grams per milliliter, which is great. But what I really want to know is how many tablets would be needed to make 250. So let's find the weight in grams to make that compound of 250 ml. And I'm going to do that with equal concentrations. I don't know my grams, but I do know my milliliters here. And so let's see, solving for x, that is going to be equal to 0.11755 times 250 is equal to, those we're going to cancel out, 4.3875 grams. So I need 4.3875 grams. Of course, these grams come in 1 gram tablets. And so I will need a total of 5 tablets, 4 plus a bit more, in order to make a solution with 250 mLs that has sodium chloride in it. So there you go. If you have any questions, reach out. Thanks.